let's do a couple of problems where we estimate or predict answers to questions using linear models. Linear models. And it sounds very fancy, but what a linear model is just using a line to describe some trend in data. And with our linear models, we will do a little bit of interpolation, and a little bit of extrapolation. You might have already heard these words before in your everyday life. Extrapolation. Extrapolation. And these interpolation means trying to estimate what happened between two data points. We're going to do a couple of examples of that in this video. And extrapolation means, well, see what the last few data points were and see what that trend looked like, and then keep on continuing that trend and see what might happen if that trend were to continue. And I'll show you some examples of that. So let's do some example questions here. So I have this chart here. Median age, remember median is the middle. So if I have the numbers 3, 7, and 9, the median is the 7. It's the middle age. So this is the median age of males and females at first marriage by year. So if we just look at this data right here, if we look at like 1900, the average man was getting married, or not the average, the median male. So the middle man was getting married at around the age, looks like at around the age, a little over 25, almost 26, while the median woman was getting married, it looks at around 22 or 23 years old. And as we went through the century, those ages got lower and lower and lower until we got to about 1960. This problem is interesting irrespective of the actual problems. It's just interesting to see this trend that at the beginning of the century, people got married, reasonably similar to when they're getting married right now, but there was kind of a minimum point. There was in around the 1960s, people got married at a younger age, and this was true for male and females. And you can also see back here the age difference between the median male and the median female. That's just gotten smaller and smaller over time. Now it's really small. So these are just all interesting things from this chart. This is the actual data from that chart. So actually, I didn't even have to estimate it here. In 1900, the median age of males getting married was 25.9. That's that right there. And the median age of women getting married was 21.9. That's that over there. So this is just a scatter plot of this data. We've just plotted each of these points over here. These in blue, these in red. Now let's do the questions. Use the data from example 1. This is example 1 up here. To estimate the age at marriage for females in 1946. Fit a line by hand to the data before 1970. So what they want to do is they want me to look at all of the data before 1970. So let's see, this is 1970 right here. That's 1970 right there. And they want to fit a line by hand to the data before 1970. Now what they mean is, and I'm going to do it, I'm just going to eyeball it. What they want me to do is to draw a line that gets as close to all of this data before 1970 as possible. So it can't go through all of these points because all of these points don't sit exactly on one line. But let me try to draw a line or a linear model for the data from, what is this, 1890 all the way to 1970. So I'm going to try my best to draw a line here that gets close to all of these points. It won't be able to go through all of them. So all the way to 1970. Maybe a line would look something like that. Let me draw a better one than that. Let me draw it in red, because we're doing with the red data. So I want to go all the way to 1970. It would have been nice to have a line drawing tool. Maybe the line might look something like that. There are actual mathematical ways to figure out the best fit line on this. We won't go into that right now. That's called linear regression. But I just eyeballed it. That line looks like a pretty good fit for all of that data. None of the data is too far away from that line. So that's what they mean by fit a line by hand to the data before 1970. This is the data before 1970. And then this, if we assume that this is a good linear model for that data, we can use it to estimate the age at marriage for females in 1946. 1946 is, see, this is 1950. This would be 1945. 1945 would be right over here. So 1946 would be right over there. So if we wanted to estimate that, if I were to figure out where that hits the vertical axis, that seems to hit the vertical axis. That seems to hit the vertical axis at around, I don't know, my best guess is, let's see, I should have zoomed in more. It hits it right about there. This is 22 and a half. So this looks like maybe 20 and a half, because this would be maybe 20 and a half years. Maybe, so I'll call it 20.5 years. Obviously, I can't do it exact, but you get the idea. I am interpolating. I am looking at, well, I'm using the model to do it. I won't use necessarily the word interpolation yet. We're going to do a much more direct form of interpolation later on in this video. But here I fit a line, and then I just use that line as a model to estimate what was the median age of women in 1946. Let's do part 2. Use the data from example 1 to estimate the age at marriage for females in 1984. Fit a line by hand to the data from 1970 on in order to estimate this accurately. So now they want us to fit a line from this data on. So let me make a line. So fit a line by hand from the data 1970 on. So let me draw a line that gets close to all of these points. That gets close to describing all of these points. Maybe it looks like something like that. Not all of them sit exactly on the line, but they're all pretty close. And if we assume that this is a good linear model, I haven't done it mathematically, I'm eyeballing it. But let's see what it would be in 1984. This is 1990. So 1984 is going to be right around there. So that looks it looks amazingly similar to the median age of men in 1970. So we can actually get the exact number. It's about 23.2. So this looks to be about 23.2 years. Now part 3, use the data from example 1 to estimate the age at marriage for males in 1995. Use linear interpolation. Now we're going to do a more direct form of interpolation. We're not going to use a linear model, or we're not going to fit a line. We're going to use linear interpolation between 1990 and 2000 data points. So we're looking at men now, so I'll do it in blue. Between 1990, that is 1990, and that is 2000 for men. So if I were to draw just a line there, we could assume that the trend would have looked something like that between 1990 and 2000. And they want us to interpolate what happened in 1995. So 1995 is that point right there. So this is pure interpolation. We're using the data point in 1990 and the data point in 2000, drawing a line between them, and assuming that 1995 would have been right in between them. We are interpolating between the 1990 data and the 2000 data. So if you were to try to estimate where that is, it looks like it's a little bit over 26. And actually, if we say that it's right in between these two values right there, it'll be 26.45 years. 26.45 years. If it's exactly in between, 1995 is exactly 5 years from each. So 26.45 looks pretty good. Now let's do another example. So here's a percentage of women smokers by year. And yeah, I have to say, these charts are interesting in and of themselves. Notice in 1990, there were a good number of women who were pregnant who smoked. Now, almost 18 or 19% of pregnant women smoked in 1990, and now that's down. Well, this is 2004, so hopefully this trend is continuing to go down eventually to 0%, but it went down to 10%. So there still are a percentage of pregnant women who, unfortunately, smoke. So let's do these problems. Use the data from example 2, that's this right here, to estimate the percentage of pregnant smokers in 1997. Use linear interpolation between the 1996 and 2000 data. So 1996 and 2000 data, we're going to use linear interpolation. So let me draw a line. And you could always do this much more exact if you have better tools or a spreadsheet. But I'm going to draw a line, and I want to get 1997. So 1997 is going to be right. This is 1997. It's going to be right over there. If we use linear interpolation, we are interpolating between that data point and that data point. It's a linear interpolation. We assume it's a linear trend between the two. And so this looks like it's, let me go all the way over here. It looks a little bit more than 12 and maybe 13, maybe 13% is my best estimate. Now part 5. Use the data from example 2, same example right here, to estimate the percentage of pregnant smokers in 2006. There isn't any 2006. This chart ends at 2004. So we have to use linear extrapolation with the final two data points. So this here you're going to see the difference between interpolation and an extrapolation. Interpolation, you are estimating between two data points that you already knew. Extrapolation, we're going to take the final two data points, and we're going to continue that line. We're going to extrapolate that line. So if you were to just continue this line between the final two data points, it might look something like that. So if you had 2006 out here, these are going up by 2. So 2004, 2006. We extrapolate this line. The percentage of women smoking might be, well, it looks a little bit under 10%. So maybe 9.5%. Once again, it's just an estimate, but we're just extrapolating the trend. We're assuming the trend of the last two data points continues, and then using that, it would be around 9.5% in 2006. Now maybe, that's not the only prediction you could make. You could you could extrapolate based on all of the data and get a line that looks something. Let me try to do it a little bit better than that. That looks something like that. And then this line would predict a lower smoking rate. So it depends on what data you use, what you're using to do your linear model with, and how you're extrapolating it. But anyway, hopefully you found this useful.